Hello, everyone. Thank you for attending this webinar today, organized by the Interprofessional Federation of Atmospheric Environment. IMEA brings together and shares and structures the air industry in France and internationally. It's composed by 120 expert companies specialized in air quality, and we collaborate with more than 30 public, private, and associative expert networks. Today, we will focus on air quality solutions for athletes and citizens, the opportunity to discover concrete, integrated, and efficient solutions that have been deployed this summer in Saint-Denis during the Olympics. And don't worry, a synthesis of the solutions and contact details of our speakers will be given at the end of the webinar, should you have any questions. For this edition 2024 of the World Clean Air Day, there are many initiatives around the world. I invite you to visit the cleanairblueskies.org website to discover more content and more events. So the message from the UNEP is really clear. It's time to invest in clean air now. And maybe some messages that are co-substantial, that are very relevant for today's discussion, is that there is no bad business with clean air, and it's urgent to integrate clean air into strategies on the one hand, and also the fact that it's urgent to ramp up funding for clean air initiatives on the other hand. So we need example to do so. And a wonderful example, and I'm very proud to present on behalf of IMEA members, that the fact that the whole clean air value chain has been demonstrated on one single territory during the Olympics. So it's really important to have the whole chain that can be displayed on one territory. It activates the mirror neurons, as you know. Most of our members took time to present their solution today in a very effective, compact, dynamic, and impactful way. So it will be 4-minute stops per solution. And let's open fire with Fabien Perdotti for AQM. Thank you very much.
Thank you for participating. I will just start briefly about 3 important facts about air quality. A normal person at rest inhale about 15 kilograms of air daily. And when this person is doing actually physical exercise, we can breathe up to 10 times more than when the person is at rest. So that's why it's important to assess the air quality over the time. Also, another important fact about the Olympic Games is that according to a local environmental association based in Paris, before the Olympic Games, so at the end of July, about 95% of the Olympic site did not match the World Health Organization recommendations in terms of pollutant concentrations. So knowing this, the Olympic Games organizers wanted to deploy some solutions in order to protect the athletes and the citizens from bad air quality and take informed decisions, informed actions when there were some pollution peaks and when it was observed. So basically, AQM was mandated by the Olympic Games organizers to deploy multiple sensors across the Olympic Village to accurately monitor the air quality 24/7. And in this project, we decided, in collaboration with the organizers, to monitor the most important parameters, the regulated parameters, and those parameters are NO2, NO, and ozone, and particulate matters. You can see on the slide the different sites where the sensors were deployed. Next slide, Thomas. So just to go a little bit more deeply about what the technology has been deployed in the Olympic Village. So the technology is a sensor-based technology, and we are able to monitor multiple pollutant concentrations at the same time and calculate the air quality index according to the European regulation. The calculation of the air quality index can be adapted to match the different regulation across the world, like in the US or Asia. It can be very easily modified. The sensors that was deployed on the Olympic Village are equipped with internal SIM card to automatically export the data to a web platform, online web platform. The platform is basically like the brain where all the data are collected, and you can analyze the data from there. You can edit report, set up the different alarms, calibrate the sensors, and so on. So the way that the system has been designed is we can continuously monitor up to 5 gas pollutants in addition to particulate matters. Most of the time we monitor the regulated parameters, so as explained, the NO2, ozone, and particulate matters. But for some specific applications, we can also monitor different specific gases like H2S, VOC, or ammonia, for example. The systems deployed are 100% autonomous thanks to the individual solar panels and internal batteries. So all the systems work 24/7 during the Olympic Games and after. Also, we designed the system to be extremely user-friendly in order to facilitate the maintenance operation and also to facilitate the installation and the startup. Anyone can install the system, and in 15 minutes, the monitoring can start with no problem. Just to finish, basically, the system has been challenged amongst different competitors in different sensors to multiple contests, and we had the chance to be awarded as the best outdoor multi-pollutant sensor in overall accuracy by a contest organized by the French National Air Quality Network. And there is a link here where you can later download the report and see the results of the report, of the challenge. Thank you, Thomas.
Thank you. Very impressive indeed. And now we are going to Pierre Guiton for Tekoya. Thank you very much, Fabien.
Hello, everybody. You can move straight away to the next one. I'm Pierre Guiton, the CEO of Tekoya. Tekoya is a 10-year-old company which sells eco-friendly air purifiers and air filters. We are located in Paris and near Bordeaux, so we are French. We have our own factory and R&D center in France. And up to now, we manufacture and sold and deployed 50,000 products, a good share of them not in France. Next, please. We are specialized in electrostatic filtration technology. The benefits of this technology are to have a very high efficiency filtration, no spare parts, no ultra low pressure drop, which means ultra low power usage, ultra low carbon footprint from fabrication to end of life on the whole life cycle. And it can be adapted to B2C appliances and domestic dwellings. This technology can be shaped and customized to various applications. And one of these applications is an air inlet that has been deployed in the bedrooms of the Olympic Village. And you can move to next. This solution has been proven to reduce exposure to urban pollution up to 50%, and it is compliant. It will be used during the heritage phase of the life of the Olympic Village, which will be used for students and lodgings, and so it was an important factor in the decision to deploy this solution rather than other filtration air quality solution for the Olympic Village. And that's it. Thanks a lot.
Thank you very much, Pierre. We are now moving to Nathalie from Aerofield. By the way, Nathalie, congratulations to all Aerofield teams for the Olympic Cauldron balloon and its ecological flame. It was flabbergasting the world and our souls. Thank you very much, Nathalie.
Good evening, everyone. I'm Nathalie Baum from Aerofield. Aerofield has been in business for 30 years as a world leader in large helium test red balloons, including the Olympic Cauldron balloon. And for the past 10 years, the company has been monitoring air quality using the Paris balloon which measures air pollution in the capital. And since 2021, Aerofill has been developing an innovative air filtration system called ParaPM, using ionization and electrostatic filtration. This system is specially adapted for outdoor or large indoor spaces, thanks to a high flow rate of 1 cubic meter per second. The device is highly efficient because it captures 95% of all the particulate matters, even the smallest, from 0.01 micrometer, ultrafine particles, to 10 micrometers, 10 PM10. It's modular, so adaptable to all type of space. As you can see on the slide, the ParaPM unit is a kind of tube about the size of a fridge. It sucks in polluted air and releases pure air, 95% free of PM. There are other advantages too. ParaPM consumes very little energy, around 300 watts per unit. There are no consumables required, so no waste compared to conventional mechanic filters. And maintenance is low, just cleaning about once a year. The ParaPM can be a solution to clean up all types of public sites exposed to air pollution, like subways, school playgrounds, sport facilities, urban square, construction sites, underground parkings. It has already been successfully tested in 2 schools in Paris, and it will be installed in the Lyon subway next week. Then we have another product, the Aerofilter. It's a depolluting urban furniture in the form of giant canopies based on ParaPM technology to clean up the air in large areas. It's a sort of clean air fountain, which captures also 95% of PM. Each Aerofilter includes 6 ParaPM units to ensure a very high flow of clean air. The story is that the ParaPM technology was chosen by Solideo, the Olympic delivery company, to purify the air in the athletes' place of the Paris Olympic Village this summer. Then 5 Aerofilters have been installed 150 meters from the A86 motorway traffic. They clean 108,000 cubic meters of air per hour. It's the equivalent volume of 43 Olympic-size swimming pools. An automatic triggering system based on air pollution level, weather, visitor numbers is also incorporated. The Aerofilter is also used as a shelter and public lighting. And these 5 Aerofilters are permanently established on the site. They will continue to provide cleaner air to future residents. It's a real fountain of clean air for large spaces. Thank you for your attention. It's all for
very interesting purification application indeed. Thank you so much, Nathalie. And then we move on to Eric Poncelet from Polytrack. Hello, Eric. Thank you.
Good afternoon, Paris time. Good evening, Asia. Good morning on the West. Referring to the West, I hope the games in Los Angeles 2020 will take into consideration as well the air quality as we did in Paris. It's very important, and we hope that the Americans will trigger that as well. We have 2 good news to get started with. One is that we have a new prime minister after a long wait. The second good news is that we had no PM 2.5 spikes in Paris for the past 1 year, apart from a spike in early January. So it's good news. We're still trying to analyze where it comes from. It's the first time ever we have that, but it's a very good news. And as we say, pharmacists are in trouble because people are far less sick than they were the year before. And now, this being said, Polytrack was conceived during COP21 at the request of Anne Hidalgo. and it was launched eventually following the Dieselgate from ICCT, because we realized that we needed to have very much hyperlocal data, and this is what we did. And as a matter of fact, the ICCT Berlin is online, so thank you, Johan, for being there. But you've done a great job, and next year will be the 10th anniversary of the Dieselgate. So what we've done is not to be on a fixed basis, but because we had so many mobile sensors in Paris, we decided to monitor the athlete village to be 100% sure that there was no over pollution in the village itself. Next slide. Just to summarize what we've done, because the result will be soon published, what we've done is we were lucky enough over the past 5 years to be working with a large corporation that were kind enough to dispatch and to deploy Polytrack in about 32 capitals and large and major cities in Europe. And this is what we have decided to bring to the cities. So everybody who is interested, please get in touch with us. It's really to have the hyperlocal monitoring of PM 2.5. And we focus really only on PM 2.5 at this point in time, because we do believe that they are the most dangerous of all pollutants. And it's much easier for the general public to understand what PM 2.5 are all about when we really focus on this problem. I promise Thomas to stick to my 4 minutes, so I will do. So with two hopes at the end, that the new prime minister will be a good one, and then the second hope is that at some stage PM 2.5 will come back, because otherwise Polytrack is in trouble. Thank you very much for your attention.
Thank you, Eric. I might have put too much pressure on our speakers, because they won't go over 4 minutes. Thank you very much.
I forgot to say, sorry, Thomas, if you don't mind, if you want to look at the all the mapping that we've done with PM 2.5, it's very dynamic, and we have this mapping available on these links.
Thank you very much. Please visit the dashboard of Polytrack. We'll move to Octopus Lab with Elias Van Kalster. Thank you, Elias, for being here today.
Thank you. I hope you listen to me well.
Yes.
Yes, great. So I'm going to present you Octopus Lab, or how to reduce the environmental impact of buildings and save energy while preserving the health of occupants. So Octopus Lab, we are a team of 24 experts, and we're based in Lille, in north of France, and we originate from academic research. So I'm going to talk to you about the first IAQ forecasting software in the world, and it's a breakthrough in the smart building sector. This software was used to modelize the IAQ in the athletes village. What is Indalo Supervision? So it's a platform equipped with a calculation engine that gathers real-time data about the building, so the IAQ and comfort variables, and weather and ambient air real-time and forecast data. So this to modelize the IAQ in the building in the next 24 hours. So we could just look at figures and say, well, that's great, I'm smelling the future right now. But we wanted to do more and tackle the roots of indoor air pollution thanks to this amazing software, and take control over the AHU. So to doing so, we realized that we breathe better in buildings by avoiding PM, CO2 or VOC peaks, and we also save energy and save money. We realized we could save 10 to 15% energy by controlling the AHU alone, and we also developed predictive control over the whole HVAC system as well. But well, it's not the matter of today's subject. Now we monitor more than 200 buildings, and we're about to get distributed by our new partner in the US. So that's incredible. Well, you can move to the next slide, Thomas. It's quite clear when we look at before and after Indalo Supervision. The software knows when to activate or deactivate the AHU based on forecasts and habits of the building. In this case, we reduced the usage of the AHU by 70%. And there are two ways of implementing Indalo supervision in a building, as a BMS that will control the whole HVAC system or just the ventilation system, or as a smart layer, or just a predictive module on an existing BMS. So that's it for me. If you have any question, you can contact me. And now leave the floor to Terao, right?
No, to Istia, actually. Thank you very much for your intervention, Elias.
You're welcome.
Now we are talking with Kelani for Istia Solutions. Thank you, Kelani, for being here today.
Thank you. Hello, I'm Kelani. I'm the co-founder of Istia. Yes, so at Istia, we take care about the indoor air quality, but also we reduce the energy consumption. We have been created into an European project 3 years ago, so we are a young startup. So we have two missions: impact the health, but also the environment. So in the project of the Olympic Village, we can move to the other slide. We have worked with Dalkia on two axes. The first one is the hardware. So we have worked with the architect and the Dalkia team to create a sensor personal customized modular for this occasion. So the architect choose the color, the material, but also the pollutants that we had inside. So we have a baseline, which is particle matter, TVOC, NOx index, CO2, and temperature and humidity. And because also it's modular, the sensor can be repairable at the end of the life cycle. The second axis that we have deployed into this project is the AI. So we predict the air quality in the future with 97% of accuracy. And the second AI that we also deploy into this project is the data extrapolation. So we can use the Istia sensor, but also the sensor for other company to be sure that we map the whole space of the Olympic Village. We can move to the other slide. And yes, and the last part is the operating system that we have created. So we use the prediction to actually manage the HVAC system, the ventilation system, with two goals. The first one is to improve indoor air quality, and the second one is to reduce the energy consumption. This operating system, it's linked to the Istia sensor, but also in this project, we have choice to integrate Schneider Electric sensor to be sure that all the prediction and the data will feed the predictive algorithm to have more impact on the energy consumption and also on indoor air quality. This operating system is also designed to manage more than 100 buildings on the same time. You can move to the last part. So I leave you with an image of the project. We have worked with the Dalkia team, the Schneider team. It was an amazing project, and we are looking forward to contribute to other projects. So we can move to the last part. So feel free to contact us. You can scan the QR code. We will be happy to talk with you. Thank you.
I'm sure some will do. Thank you very much, Kelani. And then we can move to Terao with Michael Trudeau. Hello, Michael.
Good day to everyone. So Michael Trudeau, I'm sales director of Terao. And so Terao is a new wet scrubbing system used to clean air and save energy. So you can move to the next slide, please. So the system is used, so the air is mixed with the water in order to, by bubbling inside the system, is a bit different compared to normal spraying system, which is used in classical web scrubber. Here, the air is mixed with the water in order to catch pollutions and mainly find ultra-fine particles. So on the Olympic Athletes Village, we have implemented 4 systems of 3,000 cubic meter per hour each. So the aim of the system is to suck polluted air from the road, for example, and the machine will put it underground in order to cool and to remove the pollution. And after that, the air is blown on the rested area, as you can see on the picture. We can go to the next slide. We'll see the system, and we can see on the left and on the bottom where the air, so the fresh and clean air, is blown on the esplanade. So we have installed 4 systems, as I said, about 3,000 cubic meters per hour, and so the pollution and fine particles are retained by the water. And regularly, on regular basis, we just have to change the water and replace by a new fresh water in order to start again to clean air, outside air. So the system can be used for outside air, but it can also be used for inside area. We can move to the next, please. And the second system has been used in the swimming pool. So it is also the swimming pool in Saint-Denis, which has been used for the Olympic Games. And here, the aim of the project was to improve the air quality inside the swimming pool by reducing the chloramine pollution in the water. By reducing this pollution in the water, we limit the pollution in the air inside the swimming pool. And at the same time, as we remove this chloramine from the water, we are able to recover some energy in order to give it back to warm the water in the swimming pool. Thank you very much for your attention.
Air and water, what else? But I know that you have been working with other companies on this project. And then I give the floor to Natalia from Vincent Air. Natalia Garmini, welcome.
Yes, hello everyone. So I'm Natalia Garmini from Vincent Air, which is an air quality engineering consultancy specializing in measurement, modeling, and expertise. The main business sector are the impact of urban and road design, the impact of industry, the indoor air quality in buildings, the impact of construction sites, and also the evolution of air purification systems, which is the main topic of today. So for the design optimization, and you can move to the next slide, please. For the design optimization of air purification system, we decided to study 3 different designs. So the first one was with an horizontal air blowing from the bottom of the seat of the bench. The second one was the 45 blowing from above to bottom of the seat. And the third one was 45 downward blowing from the top of the central barrier. So for that, we run a CFD model with a Sargent code, which gave the result shown below for the PM10 with no solution configuration and with the horizontal blowing. In the figure below, we decided to carry out the measurement at 3 different heights to check the effectiveness of the blowing, seated, standing, or pacing. And the blowing results in significant lower concentration at the bench blowing level. With these 3 different configuration, we get a maximum reduction from 44.2 to 21.7 micrograms per cubic meter for the NO2. And for the PM10, we get a maximum reduction from 15.7 to 10.8 microgram per cubic meters. And the decrease are observed as close as possible to the benches, but slightly less significant at the point of passage, as it's shown in the figures. In the different configurations, sometimes they were also increased in concentration or also decreased, but less significant. So the ideal configuration chosen was the second one, so the 45 blowing from above to bottom. You can move to the next slide. In order to verify the model's results in situ, a measurement campaign was designed. So the first one before the system was implanted, and the second one after the implantation. For this, several measuring devices were sized. At the bench level, some continuous NO2, PM10, PM2.5, and also ultrafine particles measurements were envisaged with different devices that you can see on the slide. But these devices are a little bit complex and costly to set up. So we plan to combine them with some passive sensors to measure the air quality at the air intake and at other receptor points, so it passed by, to check that they were working properly. And so that's the measurement with the microsensor. And we also wanted to combine this with some meteorological measurements to see how the dispersion was occurring at the measurement level. And for the moment, we are waiting for the go-ahead to launch the campaign, but this methodology present could be used for other situations of this type. Thank you very much.
Thank you. I see that Envera and NanoSense sensors that you used are also FIMEA members, which is a great satisfaction. Thank you very much, Natalia. Let's move to Sarah Jahit for Port 2.
Yes.
Thank you very much, Sarah, for being here today.
Thank you so much. Hello, everyone. I'm very happy to be here today to help shed some light on the crucial issue that is air quality. So I'll quickly go over Port 2 and what we do. So we are a French startup, and we've developed a 3-in-1 platform that tackles the 3 major challenges of today's buildings: air quality, energy efficiency, and comfort. We've been developing our products for the past 6 years here in Paris, actually not very far from the Adidas Arena for those who followed the games. And today we monitor more than 5,000 spaces all around the world, including the Athletes Village, which we're very proud of. Next slide, please. So in the context of the Olympics, we followed a very simple and effective process to manage air quality in the Athletes Village. So the first step is measuring air quality, because obviously you can't manage something that you cannot see. So Dalkia installed 33 indoor air quality sensors in the Olympic Village, as well as 2 outdoor sensors. These enabled us to measure continuously the levels of CO2, particulate matter, VOC, and other critical parameters. So I added all these sensors to our app, Port 2, in order to leverage the data and display it. So the app allows for real-time continuous monitoring of air quality. So basically, the organizer could see the air quality of the athletes were breathing at any time, any moment, and therefore evaluate the effectiveness of the remediation systems in place and take actions if needed or if possible. Beyond the real-time monitoring, the app will also enable several analysis post-games. As we know, the Paralympics are still ongoing, so we are still in the monitoring phase, let's say. But with all the data collected, we'll be able to have some very good insights. With CO2 data, for example, we can calculate the air renewal rate. We can also calculate the space occupancy rate, and this way we can evaluate the athletes' exposure to air pollution inside the village. We'll also be able to know if there was pollution transfers between outdoor and indoor environments. As we know, as someone said before, there were some outdoor pollution episodes during the games. So thanks to the data we've collected, we'll be able to know if these pollutants got their way into the athletes' villages. That's just some examples of the insights we can provide. 4 minutes is very short. If you'd like to know more, feel free to follow us or reach out to us on LinkedIn. And thank you.
I'm sure some people will do. It's fascinating. Thank you so much to all our speakers for making the effort to speak in English. For French people, it's a milestone, but for air quality, nothing is impossible. So thank you very much. So what's next for air quality medal team? FIMEA will try to participate to the Heritage of Paris 2024, promoting air quality solutions in sports from school to big events. We'll try to promote our members' know-how in the perspective of Los Angeles 2028. We'll keep on duplicating the demonstration of the air quality value chain by territory, as it was done in Saint-Denis, France this summer. We'll try to repeat the air quality solutions for athletes and citizens webinar we're having today in French in October 2024 for the French Clean Air Day, but also in November 2024 for the French Mayor's Fair, Salon des Maires de France. We'll plan to send a delegation in North America in 2025, maybe in March for Americana in Montreal, and many other things. If you want to partner on the air quality solutions team, please reach out to us, and we will give a warm welcome to your ideas. As promised, you have a synthesis of our speakers and of the solutions with the details, so you can write down the solutions you'd like to contact. So you have the solutions, the people, and the contact. So now we can thank our speaker again. Thank you all for your participation today and for your action in benefit to the improvement of the air quality. Happy World Clean Air Day to all. You can contact us at contact@fimea.fr, and remember the message, it's time to invest in clean air now. Thank you very much. See you soon. Thank you, FIMEA. Thank you to our speakers. Thank you all. Happy.
Thank you all.
Thank you all. Thank you, everybody.
Thank you.
Thank you very much.
Bye.